Happy Thursday, my mathematicians. Today for math, you're going to need your highlighters, pencil, glue stick, math notebook, your Envisions practice workbook with the black and white pages, and your blue resource folder. Remember not to take out your blue resource folder from your anchor binder, but just go ahead and open it up. On the left-hand side, you're going to take off the black clip. Take out the next two teach pages. So the teach page that says 3-4, on the teach box, it says a numerical expression. And then the second one says example, and then you see a rectangle that has a 6 for the factor on the left side and the numbers 30 and 4 on the top. Then go ahead and place the rest of the teach pages back in a nice neat stack. Put your black clip on, close your anchor binder, and tuck that in your basket so you can have it for the next day. In our math notebook, we're continuing on with our third unit, and this is our unit of multiplying by a one-digit factor. So we have already gone over in this particular unit. We started with multiplying multiples and using our zeros trick to help us multiply when a number has a 0 on the end in the smallest position. We then moved into estimating products, so using our previous lesson on rounding to find an approximate answer or an estimate to help us determine whether or not an exact answer would be considered reasonable. And then yesterday we were working on partial products. So we said partial meant part of the actual answer. So we were finding those small puzzle pieces to then place back together to find the final product of a larger multiplication equation. So today we're going to be moving on and continuing our work with partial products, but now we're going to be adding in our understanding of how to also use something called an area model. So we're going to go ahead and record the pages that we're going to use. So page 46 is on the left, 47 is going to be on the right. Remember, you can pause the video at any time. That way you can get yourself caught up and stay organized. Turn back to the table of contents. And we're going to insert number 46. And we're going to write the same name from our workbook, which is area models and partial products. And then you can write today's date, which is 9-24-20. Once you're done writing your table of contents, go ahead and turn back to the pages we just labeled. You're going to be placing the teach page that has our teach box with our vocabulary on the left. The side that says example, practice, reflection will go on the right. So use your glue stick. Go ahead and make your outside frame. Crisscross it through the middle. And we always push the paper close to the bottom edge of the paper and smooth up to keep enough room. And then we know that we need to write over, making sure that our page number is visible for us. Do the same thing with the right side. Crisscross to the bottom edge and smooth up. All right, so we are continuing to learn different strategies on how to multiply a larger digit factor in an easier method. So when your parents and Mrs. Ling were in school, we were taught one method only, and it was the traditional algorithm, so the traditional way of multiplying for place values. And we'll talk about that at the end of this unit. But for you, we are being told that we want to teach you multiple strategies so you have a better understanding of the process of the multiplication steps. So not just to follow steps that you really don't have any understanding of, but we need to make sure that we're understanding place value and the effect of it during our multiplication process. So at the top today, we're going to once again write our title. So we said it was called Area Models, and partial product. So we're just building off of what we did yesterday. You might be having an easier time with writing Mrs. Ling's on the edge of her paper, so it makes it a little wonky. Once you have your title, remember we're going to use our highlighter, not highlight it since you're writing in pencil right here, but just make your box around the title. So it is still standing out to remember, but we're not making it where we can't read it. So we're going to start in our teach box to look at the vocabulary that we're going to need to be aware of. So the first part says a numerical expression. So we need to understand what each of these words mean before we continue. So numerical means it's a number, but expression means, and we're going to pull that out, so point your arrow out to help define it. When we see the word expression, that means that it is a number sentence that does not have an equal sign. So this is different from when we say an equation, because an equation has the first part of equal. Equation will have an equal sign. An expression does not. So you might even want to underline. Just remember, expression does not have an equal sign. So a numerical expression contains numbers and at least one operation. So we're going to highlight with a different color those two components, numbers and at least one operation. So an operation is the symbols like an addition sign, a subtraction sign, multiplication, or a division. So an expression has numbers or digits and at least one of those operations that we just went over. The next part says, which of the following are numerical expressions, and write the answer yes or no. So if we look back at the two components of what a numerical expression is, we're looking for ones that have a number and an operation, but it does not have an equal sign, okay? So the first one has a number, but there's no operation. So this first one, we would write no. It is not an expression. The one to the right, it has numbers, it has an operation, which in this case is multiplication. So we write that this one is considered, yes, an expression. Moving down, we have numbers. We have at least one operation. In this case, we have two. So this is also considered an expression because it does not have an equal sign. And the last one, we have numbers, but it does have an equal sign, but no operation sign. So this one would be considered no. This is just showing equivalent values. So understanding how to identify an expression is going to be very important. So remember the two components, it must have numbers and operation, and it cannot have an equal sign to be considered an expression. If it has an equal sign, that means it's an equation. The next part has our next vocabulary word that we're going to be focusing on. So go ahead and highlight the distributive property. So the distributive property says that multiplying a sum or difference, remember those are the answers to an addition problem or subtraction. So we're going to just put those symbols above to remind us. So multiplying a addition sentence total or a subtraction sentence total by a number is the same as multiplying each number in the sum or difference by that number and adding the products. So this is a lot of words to explain. So we're going to use our example to have a better understanding. So this time it says for us to use the distributive property. So we're going to highlight distributive property to rewrite the problem. And I'm going to just neatly box, or you can circle your expression that they're asking us to use this property to solve. So we're looking at the original factor of 3 to remind ourselves that we say that means there's 3 groups of the second amount. So 3 groups of 546. Instead of showing our model using our flats and our rods and our units like we did yesterday, we're still going to use the break apart method. So I want you to underline break apart. That's where we find the expanded form in some cases. We'll talk about other cases where it's not necessarily the expanded form, but we're using more compatible values to be able to break it apart, to be able to multiply a little bit easier. So looking at the original number, So I'm going to, once again, I'm going to just box it to remind myself this is the problem I'm solving for. I'm breaking it into a more manageable and more understandable position. So our 3 will not change. This 3 still stays the same. It's still saying there's still 3 groups for each. My second factor, 546, is going to be pulled apart. So we're going to break that apart. You can see that the 5 in the hundreds place is already brought out as its value inside the parentheses. The 4, which is in the tens place, needs to be brought out. So if the 4 is in the tens place, that means there's a 40. The 6 in the ones place stays 6 by itself. So inside the parentheses, I pulled apart, or I broke apart, the value of 546 to show the individual values. Now, to show the distributive property, we're going to distribute the 3 groups to be separate problems to each of the pulled apart values. So distribute means that I'm taking something and I'm moving it to another location. So I'm still going to continue with the 3, but I'm going to attach it to each value. So you'll see that if there's 3 pulled apart values, we're going to have 3 separate problems. So the 3 has to be in each of those 3 separate problems. And we continue to keep the 3 in the front. So there's still going to be 3 groups. And then we pull down the values. So the first value is 500. So I pull it to my first problem. The second value of 40, I pull to the second problem. And the third value of 6, I pull to my third problem. So originally when we had our number 3 times 546, we used distributive by pulling apart the larger factor to show individual values. To distribute, we then rewrite the original group that we're multiplying in separate problems, and we pull down the values for each of the expanded form or each of the broken apart value. When we bring down and make separate problems, we always contain them in parentheses to say, this is the information I need to solve for before I move to the next problem. So this is what we're doing. We're not going to be solving for the answer right yet for this particular example. So it just says to distribute the 3 to each add-in, and that's what we just showed in the example. When we move to the next example, we will continue to solve to find the actual product. This one we were not. We were just leaving it in an expression, but using the distributive property to show. So once again, we're going to start with our original problem. So we're starting with 4 groups of 613. So I'm going to remember that 4 is going to remain the same. So I'm going to keep my 4 groups at the beginning of the problem. The next step is to then distribute or to push the 613 into separate values. So we are breaking this apart. So the 6 is in the hundreds place. So that tells me 600 is the first value. The 1 is in the tens place, so there's 110, that makes just a 10. And there's a 3 in the ones place, so that means 3 stands alone. Now that I've broken my problem into values, I can distribute the correct information in the separate problems. So because we have a 3-digit factor, that means 3 separate problems. When I look at the information that they've already provided, they've already brought down the broken apart values. So that will help me determine what is the missing information. If we look back at the example we had previously, the original factor that we then labeled with the groups that they have were repeated because it didn't change. We're moving the groups to each individual problem. So that tells me this 4 needs to be distributed to the first problem. It needs to be distributed to the second problem, and it needs to be distributed to the last problem. Instead of highlighting, since you're writing in pencil, just go ahead and put a little underline to show that that has not changed from the original. Now that we have our 3 separate problems, we are moving to the next step that we didn't have to originally in the example. So now we have 3 separate problems. We need to find the 3 separate partial products. So we said that's part of the final answer. So I solve for the first information. So when I have 4 times 600, I can take those zeros, place them directly on the first line for my partial product. Then I would have the basic fact of 4 times 6 to give me the number 24 that gets placed in front of the zeros for that zeros trick, and I put my comma to show the break in the period. The second problem, I do the same work with my zeros trick. I take the 0, place it in the second answer line for this partial product, and I'm left with a basic fact 4 times 1 to place in front to make this a 40. My third problem is a basic fact by itself. 4 times 3 gives me the partial product of 12. So now I have 3 partial products that we call add-ins because they need to be added together to find the final answer. Because we're adding, we should know that Mrs. Lang always wants us to stack our add-ins to line up the place values so you can ensure that you are adding the correct values to get the right answer. So we just pulled those 3 add-ins to the side. So we have 0 plus 0 plus 2 leaves there a 2. 0 plus 4 plus 1 gives me a 5. The 4 in the hundreds place gets brought down because there's nothing to add. The 2 in the thousands place gets brought down because there's nothing to add, and my comma gets placed in the correct position. Because I just found the total product, which means it's the end result, I rewrite this value, 2,452, on the final answer line. We're going to move to the next one and do the same type of work. So I'm going to look at the original problem of 5 times 792. I need to remember that the first factor is what we consider to be the groups. How many groups of 792, what is that going to equal? So the groups is repeated, but this time we're going to use a different strategy than breaking apart into expanded form. We're going to use something new that I referred to as compatible numbers before. Compatible numbers means that I'm still going to use this value, but the problem is going to be a slightly different way to get there. So instead of just pulling those numbers out, I have to think, well, I want to make this as easy as possible for when I start multiplying. So I can use either an addition sentence or a subtraction sentence to find the actual value of 792. When I start multiplying a large number, I know that it's typically easier to multiply a multi-digit factor when I can use my zeros trick. So if I place a number that is slightly larger, meaning I'm rounding up to the hundreds place, so I rounded 792 up to the number 800, I have to determine what is going to be the number I need to show that needs to be taken away to still represent the same value as the original. So we used rounding to get to a number that we could use in multiplication, but we have to still represent the original value contained in the parentheses. So 800, and we need to go back to 792, we can even show that to the side. 800 minus 792, and whatever the difference is will be my second number contained within that parentheses. So this is why we practice the subtracting across zeros. So if we go next door, we can't borrow, so we go to the 8, that leaves us with 7. This is going to be a 9, the 0 is turned to a 10. So 10 minus 2 leaves me the difference of 8. 9 minus 9 leaves me the difference of 0. 7 minus 7 leaves me the difference of 0. So this number 8 is going to be placed in that parentheses to say that 800 minus 8 is still the original value of 792. We are using compatible numbers to still show the value, but it's going to be in a more understanding way to do our multiplication. So now we're going to use the distributive property to distribute that original grouping number, so groups of 5, to both problems that are representing with these 2 digits. So I'm going to go ahead and show how the 5 gets placed down because we have 2 numbers to then place. My 800 gets moved down, and then the 8 gets moved down. And my glue is still a little wet, so that's an 8. When I multiply now, this is going to be a little bit easier, more manageable to multiply because I was able to round it up to the hundreds place for that original number. So using the zeros trick, I take the 2 zeros, place them on the partial product line. I'm left with my fact family or basic fact of 5 times 8 to give me 40. Remember, we talked about the importance of if your basic fact has a 0 in the end of the product, you have to make sure you place it and don't assume that one of the zeros you're already placed really represents it, because you'll have the wrong value and you might have wrote 400 instead of 4,000. And go ahead and place your comma in the correct position. The next spot, we would multiply 5 times 8, and that's our basic fact, so that will be 40 by itself. Now, something so incredibly important, because we were using compatible numbers and we were not using the break apart or expanded form. Expanded form meant we were going to be adding the pulled apart values, but the compatible numbers, if we use the subtraction sign to show how we then still created this to be the original value, we have to pull down that subtraction sign to still be there. Because if we don't and we accidentally put an addition sign instead, we're going to get the wrong final product. So if our original compatible numbers, we were showing the value of 792 by subtracting, we have to show this is going to have a subtraction sign and our final problem will have a subtraction sign. Now we can go ahead and solve. We always want to bring our numbers out to the side to either subtract or to add to line up our place values. And once again, this is our subtracting across multiple zeros. So if we can't go next door, we do the box method where we box those values. We take 1 away from that box number. So if it was 400, now it's 399. And then if we don't need it here, we can then place that number back to be a 10, because the zeros really were going to be a 0. So we could have just boxed the 40 instead. So we have 10 minus 4 to give me 6. The 9 gets brought down. The 3 gets brought down. Our value is 3,960, which gets placed on the actual answer line. Both of these methods are what we are supposed to be using, either the break apart method, pulling them into expanded form, which is the more understandable method, but we're also supposed to expose you and for you to start practicing using compatible numbers. You will see this term quite a bit in our upcoming lessons. So compatible numbers means numbers that we can work with a little bit easier with our problem solving. The final part is on our right side. You're going to look at the example. This is the area model part of our lesson. So an area model is where we are able to demonstrate showing the value of the original numbers by showing the distance a rectangle is drawn. So when we have our problem, on the left side will be the first factor typically, and the top will be the second factor. If you see an area model that has 2 sections, that means that they've already used our break apart method. So they're using expanded form. So if we were to find the original number, we would say that 6 is the first factor. So I'm going to just mark it down. But if I were to then add those values back together, my original factor would have been the value of 34. But because we're using partial product, they've already separated it for us originally. So I'm going to go ahead and pull the partial product down to our problem so we don't have to do the work again. So we're going to say times the parentheses of 30 plus 4. So when we see this, we now can distribute the original factor and have 2 separate problems. And I know it's 2 separate problems because there's 2 numbers to my expanded form. So the 6, or before we put the 6, if there's 2 problems, I'm going to right away set up what we call our problem solving format. So we're going to put 2 parentheses to represent the 2 separate problems we're about to create. So the 6 that I'm using as the groups is going to be distributed to the first position in each problem. So I'm going to put a 6 times 6 times. Now the number that they've used for the expanded form is placed separately as the last spot in each problem. So the 30 gets distributed to the first problem, the 4 gets distributed to the last problem. Now we can find the partial products by using our zeros trick. So the 0 gets placed down. The basic fact 6 times 3 is 18 is my first partial product. Because we're using expanded form, we're still using addition symbols. The second basic fact 6 times 4 is 24. You will see that in this method, we're using our rows to keep track of our solving. And now we're going to push those two values together. And like we said before, you will want to rewrite your addition sentence, stacking your numbers to ensure you're lining up those place values. So 0 plus 4 gives me 4. 8 plus 2 is 10, so I record the 0 in the ones place, regroup the 1 and the 10. 1 plus 1 is 2. So my overall number is 204. This is the original problem that we use the partial product to solve for. So you will not need to solve for it again because we already used it with the partial product. The second way of looking at the original problem is 3 times 185, which is our horizontal expression. This is a stacked, this is the horizontal. So once again, we're using area model to represent this in a quick picture or a quick little model. The group number, the first factor, is represented on the side of the rectangle. The second number, or the second factor, is using the expanded form value. So the 1 in the hundreds place is represented with the larger part of the rectangle. The 8 in the tens place is slightly smaller. And the 5 in the ones place is the smallest position. So when we bring those numbers down to represent the pulled apart or expanded form value, we say 100 plus 80 plus 5. So still looking at the original, but we've already pulled it apart to expanded form. The next thing we're going to do, we count how many numbers we pulled apart. So we have 1, 2, 3 numbers pulled apart. That means there's going to be 3 separate problems. And because we're using expanded form, we put additions problem symbols between those problems of the parentheses. Now we're going to pull that group number that never changes because we're keeping it the same. We're going to place that in the first position of each of the separate problems. So go ahead and write the 3 in the first spot. The multiplication sign comes next. So put your multiplication sign. And now we're going to place one of our expanded form numbers in each separate problem. So the 100 comes in the first problem, the 80 comes in the second problem, and the 5 goes to the last. Now we can use our zeros trick and solve for each of the partial products. So 2 zeros down, basic fact, 3 times 1, place in front to make a 300. Bring your addition symbol down because we haven't used it yet. The second problem, using the zeros trick, put that in the next partial product. Basic fact, 3 times 8 gives me 24. Put that in front to make 240. My last basic fact is 3 times 5. We should be able to quickly write that down as a 15. Now we have our 3 partial products, which are now add-ins. We need to then put them together to find the total, which will be our final product. So once again, we're going to pull our numbers to the side because I want you to always get used to stacking your numbers to do your addition or subtraction, depending on what it is. We add 0 plus 0 plus 5 is 5. 0 plus 4 plus 1 is 5. And then 3 plus 2 is 5. So we write our final answer on the next row and circle it to say my final product is 555. The last thing I want us to look at now that we've solved is how can we place information within our area model to help keep track. So when we look at the first number, 6 times 30, that was our first problem in parentheses. We said 6 times 30 was 180. I want you to also get in the habit of placing that product for those two values within the contained rectangle. So then the next rectangle, we use the same grouping number, 6 times 4, which was the second problem. 6 times 4 we said was 24. So we place that in the second rectangle because we want to be able to represent when we put those two values back together, that will be the final product. The same thing goes for the second example. So we had 3 separate problems. There are 3 separate rectangles. The first problem, 3 times 100, which is the first problem, we said was the product of 300. So we put the 300 in the first box. The second problem was 3 groups of 80, which was the second problem, was the number 240. So we're going to place that back in the second box. And then the final problem, represented by 3 times the number 5, we said was the total of 15. So even though that box is really tiny, you can still kind of write it over top of it. So in order to see what this area model represents, we would push those numbers back together to find a sum, which in this case represents the product of 555. This next problem is your practice problem. This is a multiple step question. So you're going to have a hidden question that I want you to solve underneath this label. So you have to figure out what is the hidden information first that you need to solve so you can use it to find the actual question. So there is a part you need to solve for first, and we're going to call that the hidden question. And then how can you use the hidden answer in your actual question? So solve for this one, and when you take a picture of your completed work pages today, make sure this is completed using problem-solving strategies of underlining, boxing, and circling. When you have your final answer, remember to label it. The last thing to do on this page is to write your reflection statement. Remember, that's 3 to 5 sentences using capital letters, punctuation mark, and to make sure that those sentences are complete. I want you to walk through in your transitional way to say the steps in order to solve a partial product problem. So what would you do first? What's the second step? What's the third step? And then how do you find your final answer? So remember, you have steps that you can use in describing your reflection. When you're done with that, you're going to do your classwork in your Envision practice workbook today. It is on page 33 and 34. At the top, it'll say 3-4, use area models and partial products to multiply. You are only solving for the even numbers. So you will see the first 2 on the front side are just like what we've practiced in your notebook. So look back at your notebook for an example, and it should be a guide to how I want the work shown for both of those problems. Then when you turn the page over, you have problem 6 and number 8 that are going to be word problems. Remember to underline your question, box keywords, circle important numbers and labels. Number 10, you're using the chart, so make sure you're looking very carefully at what the chart explains that it represents and how are you using that to solve with. And then number 12 will be your final problem. So when you're done, take a picture of your completed workbook, your notebook pages, and then including your classwork on both sides.